Okay, we're going to talk about whether or not the market allocation will also be an efficient allocation. Let's consider what is the efficient or optimal quantity of any good or service. Of course, the formal definition in economics is the Pareto-optimal allocation. But it turns out that it is pretty difficult to see a Pareto-optimal allocation directly in a diagram. So we're going to change our definition of efficiency or optimality just a little bit. We're going to say now that the efficient quantity is the quantity of the good that maximizes net social benefit, where net social benefit is defined as the difference between total social benefit and total social cost. Note, each part of the definition is considered a function of Q, or the quantity of the output. Total social benefit will be a function of how many units of the good are provided, and total social benefit is considered what all in the community benefit from the good itself. Total social cost is also a quantity, is a value that's determined by the quantity of the output Q produced. As always, in economic terms, cost is an opportunity cost. So total social cost is the value given up in other goods and services when resources are used to produce this good instead of the other goods. Now, thinking like an economist, we think at the margin, and we can identify a necessary condition that will identify the optimal quantity of the good. And that necessary condition for efficiency or optimality is that Q star, the efficient quantity of the good, is determined where marginal social benefit equals marginal social cost. You probably know, and if you're not, here's the definition. Marginal social benefit is the increase in total social benefit when another unit of the good is provided. Marginal social cost is the increase in total social cost when another unit of the good is produced. Now there are three possible circumstances that we might see. Marginal social benefit might be greater than marginal social cost. Marginal social benefit might be less than marginal social cost, or marginal social benefit might be equal to marginal social cost. If marginal social benefit is greater than marginal social cost, from an efficiency point of view, Q should be increased in order to increase net social benefit. Whenever marginal social benefit is less than marginal social cost, increasing output, or Q, will actually decrease net social benefit. So, from an efficiency point of view, if the circumstance is such that marginal social benefit is less than marginal social cost, there should actually be less of the product, a decrease in the quantity. Only in that third circumstance, when marginal social benefit equals marginal social cost, will net social benefit be maximized. Therefore, our general necessary condition for efficiency that we use in our models to identify the efficient or optimal quantity of the good is the quantity of output at which marginal social benefit equals marginal social cost. And this is true from an economic point of view, from an economic efficiency point of view, for any good, such as gallons of gasoline or bottles of beer, or the number of red Cadillacs, or the number of bald eagles, or the amount of clean air, or the amount of clean water. The efficient or optimal quantity of something like bald eagles is where the marginal social benefit equals the marginal social cost. So let's look now at a graphical depiction of the optimal allocation model. Let's start with the axes. We've got the quantity of the good, units of the good on the horizontal axis, and dollars measured on the vertical axis. Here's the marginal social benefit curve. It's downward sloping. It depicts the idea that at the margin, people in the community will be willing to pay less for each additional unit of the good. Now this is the marginal social cost curve, It's upward sloping. It expresses the opportunity cost to people in the community, and it has a positive slope, reflecting the idea that the cost to people in the community increases as more resources are taken from the production of other valuable goods and services to produce additional units of this good. Now, the intersection of marginal social benefit and marginal social cost identifies the optimal quantity, the output, Q star. Let's consider a quantity Q1, which is less than Q star in the diagram. This is a quantity that's associated with, as you see in the diagram, marginal social benefit is greater than marginal social cost. As we said before, from an efficiency point of view, this implies that there should be more units of the output. Consider also a quantity, Q2, greater than the efficient quantity Q star. At this point, with Q2 units of the good, marginal social cost is greater than marginal social benefit. So as we said earlier, from an efficiency perspective, there should be less of the output produced in the community from the efficiency point of view. Now, this last idea may seem kind of odd. After all, if we could have more of something we value, why not have more? It's a good thing after all. Well, here we probably see the importance of thinking like an economist. We economists, the opportunity cost reflected in the marginal social cost curve. And with the quantity Q2, the value to people in the community of other goods given up is greater than the value to the same people in the community of an extra unit of this good gained, whatever it is. This idea is probably the economic meaning of the phrase, "it costs too much." Beyond Q star, people in the community in total value goods and services given up more than they value additional units of this good gained. Okay, let's see how this optimality model that maximizes net social benefit is consistent with our formal definition of efficiency as Pareto optimality. When we think about social benefit will involve increased well-being by individuals in the community, and social cost will involve decreased well-being by individuals in the community. Thinking like an economist, we focus on each individual. If a person is better off, she enjoys a benefit. If a person is worse off, she experiences a cost. When we say total social benefit, we mean the summation of all individual benefits in the community, and by total social cost for the community, we also mean the summation of all the individual costs in the community. Think about either of the circumstances that do not maximize net social benefit. If the allocation does not maximize net social benefit, then it has to be possible to change the allocation in a way that will be a Pareto improvement. After all, those in the community who benefit from either an increase in Q or a decrease in Q, moving in either case in the direction of the optimal quantity Q star, they will gain a value, a sum, greater than the sum to cost to the others in the community. And this means that those who gain could more than compensate those who lose. This is the very meaning of a Pareto improvement. It means a Pareto improvement is possible. So, this optimality model tells us a lot about how economists think about government policies and actions. When an economist says, from the efficiency perspective, that policy X is a good policy, the meaning is that it is thought by the economist that the policy will either maximize net social benefit, or, at the very least, it is thought that policy X can result in a Pareto improvement by causing the allocation to get closer to the optimal quantity, Q star. Now we come to the key question for this lecture. Will the market allocation be efficient? We have two market allocations to consider. First, the allocation which results with a perfectly competitive market, and second, the allocation associated with a monopoly market. Here we have a picture of our perfectly competitive market allocation. The demand curve shows the quantity buyers will want to purchase at each price. The supply curve shows the quantity the sellers will want to sell at each price. Now, the market allocation model depicts the results of a large number of pairwise voluntary social interactions. I emphasize that the world we see around us with respect to the market process is made up of separate pairwise social interactions between a buyer and a seller, and that there are a very large number of such social interactions. Now, the market equilibrium allocation is shown by the intersection of the supply and the demand curve. It is shown by the market equilibrium price PE and the market equilibrium quantity QE. This equilibrium depicts the market allocation of resources. Now, before answering the question of whether this market equilibrium quantity QE is efficient or not, I want to remind you of the characteristics or the conditions of perfect competition. The first is that there is a homogeneous product. Every seller is selling the identical product, the same thing. There's a very large number of buyers, also a very large number of sellers. The buyers and the sellers are assumed to have complete information. They know everything they need to know to either maximize profit for the sellers or maximize utility subject to a budget constraint for the buyers. It is also assumed that there's costless entry and exit and that there is price-taking behavior for all the buyers and all the sellers. Will the perfectly competitive market allocation be efficient? Looking at the optimality model and then looking at the market allocation model, they look a lot alike. They just might be the same. And if demand equals marginal social benefit and supply equals marginal social cost, they are the same. And that's usually what we expect. So the answer is yes. The perfectly competitive market model will allocate resources efficiently. The market equilibrium quantity QE will also be the quantity that maximizes net social benefit. Well, what about if the market is a monopoly market? Here we see a model of the monopoly market allocation. It turns out that the monopoly equilibrium is QE and the price is PE. Again, assuming demand equals marginal social benefit, and in this case, that marginal cost of production, MC, is also the marginal social cost, then notice at the equilibrium quantity QE for the monopoly, marginal social benefit is greater than marginal social cost. So, QE, the monopoly output, is inefficient. We can also say the efficient quantity is Q star, and that from the efficiency point of view, a monopoly market will produce too little output. So, will the market allocation be efficient? The answer is only when the market is characterized by perfect competition. If there's monopoly or any source of market power, then the answer is that the allocation will be inefficient. Oh, and by the way, I should make it clear. Note that these conclusions are reached with models in which we are assuming there are no sources of market failure, such as the externalities and public goods I introduced to you in an earlier lecture.